When we think about the internet, we usually imagine an invisible cloud floating around us. But it is actually a massive physical infrastructure made of glass and steel, requiring data to travel across vast geographical distances. Even though data travels as pulses of light through these cables, light itself still has a speed limit. When your request has to physically travel thousands of miles across oceans and continents, it takes time. We call that physical delay latency. This simple bar chart shows how latency directly impacts a business. As you can see, a tiny 1-second delay in a page loading correlates to a solid 7% drop in e-commerce sales. People simply leave. Since we cannot make light travel any faster, engineers solved this physics problem another way. They moved the data closer to you. This is the purpose of a content delivery network, or CDN. Achieving true speed on the modern internet relies entirely on shortening the geographical distance your data has to commute. To understand how a CDN works, start with the origin server, a company's central headquarters for original files. Instead of everyone traveling there, a CDN surrounds it with local branches globally, called edge servers. DNS routing acts as a traffic controller. When you click a link, it instantly connects you to the closest edge server. This is caching. The edge server fetches a file from the origin once, saves it, and serves copies locally instantly. By dividing the work through this hub-and-spoke design, the central headquarters is protected from exhaustion, and users everywhere get immediate access. But a CDN cannot copy everything. Files identical for every single user, like background images, streaming video clips, and website layout code, are called static content. These are perfect for keeping at the local edge. On the other hand, things like your unique shopping cart, personal bank balance, or live inventory numbers are called dynamic content. Because they are unique to you, they must be fetched directly from the main origin server. When you offload heavy, repetitive static files to local CDN branches, you free up massive amounts of processing power at the main headquarters. This smart network strategy divides labor. Local servers handle identical files, allowing the central server to focus exclusively on your personalized tasks. Without that division of labor, a single origin server is completely exposed. If a major global event or a flash sale drives a massive surge in demand, an unprotected server can easily buckle under the weight. A distributed denial of service, or DDoS attack, weaponizes this exact vulnerability. A malicious network of computers floods a target server with millions of fake requests to force it offline. Because a CDN is a distributed network, it acts as a physical shield, filtering malicious data packets across global locations before they reach headquarters. Even with legitimate surges, load balancing distributes traffic across edge nodes, preventing single machines from overheating. These networks do the heavy lifting for delivery speed, and they serve as the critical security barriers keeping our digital economy functioning under extreme pressure. This infographic maps the next phase of the internet, edge computing. In this setup, edge servers take on a more active role, running code and processing data locally, right where the user is. By crunching data directly in your city rather than across the world, complex tasks like artificial intelligence decisions and real-time personalization can happen in milliseconds. When combined with 5G mobile networks, which remove the slight delays from cell towers, these local computing capabilities become virtually instantaneous in the palm of your hand. Every CDN is built to conquer that physical distance, saving bandwidth, blocking attacks, and reducing the delay of latency to its absolute physical minimum. The seamless, high-definition digital experiences we rely on every day happen because a globally distributed physical network works tirelessly behind the scenes, ultimately making the world smaller and faster.